TechInFive.
Python in practice, master real-world projects in 5 minutes. Build a Docker container with Python for a machine learning environment. Follow along to set up your machine learning workspace. Hello and welcome to our tutorial on setting up a machine learning environment with Docker. Today, we're going to build a Docker container equipped with Python and some of the most powerful machine learning libraries available: scikit-learn, Tensorflow, and PipTorch. By the end of this video, you'll have a fully functional ML environment ready to go, which we'll use in upcoming tutorials to dive deep into each library. Let's get started. First, let's understand Docker files. A Docker file is a text document that contains all the commands a user could call on the command line to assemble an image. Using Docker build, we turn a Docker file into an actual image that can run on Docker. Let's break down the key components. Every Docker file starts with a from command, which specifies the base image to use for building our Docker image. This sets the foundation for the environment in which our application will run. Next, the work_dir command establishes the working directory inside the container. This is similar to using the cd command in Linux, setting the stage for subsequent commands like run and copy. The initial run command updates the system's package index and installs necessary dependencies. In our case, we're installing libhdf5dev, which is mandatory for the h5py Python library. Following that, the copy command transfers the requirements.txt file from your local computer into the container. This file lists all Python packages our application needs. Another run command follows, which handles the installation of Python packages listed in requirements.txt using pip. This step ensures all our application's dependencies are installed inside the Docker image. Then, we use the copy command again to transfer all files from the local app directory into the container. This includes all our application code and any additional resources needed. Finally, the cmd command is set to run Python app. This command starts our application by executing the file when the container is launched. Now, let's take a look at the files that are copied into the Docker container in our Docker file. The requirements.txt file lists essential Python libraries. The subsequent run pip install command uses it to install these libraries within the container. The app file is a simple Python script that's also copied into our container. Its purpose is to demonstrate that the Python environment is correctly set up and functioning. When executed, it prints a message. Now, we can use the docker build command to create our Docker image. This command takes the instructions we've written in our Docker file, like setting up the working environment, installing dependencies, and preparing our application files, and executes them to build a static Docker image. This image serves as a blueprint for our application and its environment. In our Docker image, we're installing 3 foundational libraries that are pillars in the machine learning community: scikit-learn, Tensorflow, and PyTorch. Scikit-learn is renowned for its simplicity and accessibility, providing a wide range of straightforward tools for data mining and data analysis. This library is ideal for those beginning their journey into machine learning, as well as for building complex models with ease in a production environment. Tensorflow, developed by Google, is a powerhouse for numerical computation using data flow graphs. It shines in deep learning applications because of its flexible and comprehensive ecosystem of tools, libraries, and community resources that allow developers to construct sophisticated neural networks. PipTorch, developed by Facebook's AI Research Lab, offers an intuitive interface for building deep learning models. It's favored especially in the academic and research sectors due to its ease of use and dynamic computational graph. Now the image is built, we use the docker run command to create a new container from this image. When we run this command, Docker takes the static image and creates a live running container from it. And there you have it. We've successfully built a Docker image equipped with Python and 3 of the most influential machine learning libraries. Thank you for joining me in this tutorial. In our upcoming videos, we'll explore practical examples and advanced techniques to fully leverage the power of this environment. So, stay tuned, keep experimenting, and happy coding.
Stay tuned for more videos on TechInFive.